In this video, let me consider one numerical on node analysis. For the network shown below, find node voltages Vc and Vd. So here we have four nodes. A, we have here we have B, here we have C, and here we have D. We have to find voltages at C node and voltage at D node. We are supposed to solve using node analysis. So this is the given circuit. Let me assume voltage at node A is VA. Let voltage at node B is VB. Let voltage at node C is VC. Let voltage at node D is VD. So in node analysis, the first step is mark all branch currents. So here we have a current dependent voltage source. It is dependent on current I1, where I1 is flowing in 2 ohm resistor. Let me assume current through this branch is I2. Current through this branch is I3. Current through this branch is say I4. So here there is a voltage source connected directly between A and D. We should not mark current direction. Here there is a current source. Here there is a current source. So from this circuit, we can observe that VA, VB, VC, VD are non-reference node, and this node we will assume it as reference node. The voltage at this node is 0. It is like grounded. So we have to find all voltages with respect to this reference voltage. So from circuit we can say that voltage at node B is 8 volt. As 8 volt is directly connected between node B and ground, I can write VB is equal to 8 volt. So we found voltage at node B, that is VB is equal to 8 volt. So from the circuit we can say that node A and node D are super nodes, as voltage source is directly connected between A and D. Here node A and D are super nodes. So if the nodes are super node, then we have to analyze super node first. So here we can observe that plus terminal is connected to A, minus terminal is connected to D. I can write VA minus VD is equal to 6I1. Let me call it as equation 1. So now here we can see that I1 is the current which flows through 2 ohm resistor. So I can write here I1 is nothing but VB minus VC divided by 2. VB minus VC divided by 2. So let me substitute I1 value in equation 1. So I can write VA minus VD is equal to, we have 6 in bracket, we have VB minus VC divided by 2. I can simplify this as VA minus VD is equal to 6 in bracket, VB is nothing but 8 volt, that is 8 minus VC divided by 2. Or I can write it as VA minus VD is equal to, we have 6 in bracket, 8 by 2 is 4, minus it is 1 by 2 VC, that is nothing but 0.5 VC. So or I can write it as VA minus VD is equal to, we have 24 minus 6 into 0.5 is 3 VC. Or I can represent it as VA minus, or I can write it as VA, I'll take 3 VC on left side, plus 3 VC minus VD is equal to 24. Let me call it as equation 2. So now, as I said, node A and D are super nodes. We also know that algebraic sum of currents at super node is 0. So that is algebraic sum of currents at super nodes is 0. So here we can identify the currents at node A. So at node A, here the currents are, one current is I2, another current is I3. So at node A, current I2 is incoming, I3 is outgoing. So I can write for incoming current I'll use positive, that is plus I2, and I3 is minus I3. So similarly, let me see what are all currents are entering and leaving at node D. That is, now I can observe at node D, here the currents are 3 Vc is incoming, I4 is leaving. So I can write 3 Vc and I4 is leaving, I can take it as minus I4. So now algebraic sum of currents at supernodes is 0. So A and D are supernodes. The sum of this current is equal to 0. That is I2 minus I3 minus I4 plus 3 Vc is equal to 0. That is algebraic sum of currents is equal to 0. Now let me express these all currents in terms of node voltages. That is, now I can write I2 is nothing but, here we can see I2 is Vb minus Va divided by 2, Vb minus Va divided by 2, minus we have I3 is nothing but Va by 2, I3 is Va by 2, minus I4 is nothing but Vd minus Vc by 2, Vd minus Vc divided by 2, we have plus 3 Vc is equal to 0. Let me simplify this. So Vb, so here Vb is nothing but 8. 8 by 2 is 4, minus Va by 2, that is 0.5 Va minus 0.5 Va. Here it is Vd by 2, that is minus 0.5 Vd, minus minus plus Vc by 2, that is 0.5 Vc, and here it is plus 3 Vc is equal to 0. Or I can write 4.5 Va, 0.5 Va is Va minus Va, and here we have 0.5 Vc plus 3 Vc is nothing but plus 3.5 Vc. Now let me write Vd, that is minus 0.5 Vd. Or I can write minus Va plus 3.5 Vc minus 0.5 Vd is equal to minus 4. Or I can write Va minus 3.5 Vc plus 0.5 Vd is equal to 4. So let me call this as equation number 3. Call it as equation 3. So here Vb node is over, Va and Vd are super nodes. The left out node is Vc. So this is independent node. Now we are supposed to apply KCL to node Vc. Apply KCL to node Vc. So that is KCL is incoming current is equal to outgoing current. Here I1 4 and I4 are incoming, outgoing is 0. So I can write I1 plus 4 plus I4 is equal to 0. That is I1 plus 4 plus I4 is equal to 0. So I1 is nothing but Vb minus Vc divided by 2 plus 4 plus I4 is nothing but Vd minus Vc divided by 2 is equal to 0. So here Vb is equal to 8. So 8 by 2 is 4 minus Vc by 2 is nothing but 0.5 Vc plus 4 plus Vd by 2 is 0.5 Vd minus 0.5 Vc is equal to 0. Let me simplify, that is So here 0.5 Vc minus 0.5 Vc is minus Vc, and here we have plus 0.5 Vd, and here we have 4 plus 4 is 8. I'll take 8 on other side, it will be minus 8. So let me call this as equation number 4. So now we supposed to solve equation 2, equation 3 and equation 4 to find Vc, Va and Vd. That is solving equation 2, 3 and 4 we get. So here equation 2, 3, 4 can be solved directly using calculator. Keeping calculator in equation mode, choose number of unknowns as 3. So here one of the unknown variables are Vb. Here the variables are Va, Vc and Vd. So directly feed the values in calculator and we will get the results as Va is equal to 9.14 volt. So anyhow Vb is 8 volt. Vc will be equal to minus 1.14 volt, and we have Vd is equal to minus 18.28 volts. So here the in question it is asked that Vc and Vd. These are the Vc and Vd voltages. Thank you for watching.